Hello students, welcome all to my mentor math class. Students, how is your Josh? Hope it's high. And now today I am going to start a question answering session regarding limit topic. And introduction part of this topic already mentioned in this description box. Those who miss the class definitely go through that link and clear your concept. Hope you understand students. So now let's start the class. So students, today I am going to discuss about one important question regarding your limit topic. And in my previous class, I already discussed and cleared the what is the basic meaning of limits and what is the basic geometrical concept, basic meaning of geometrical concept, as well as algebraic concept I already clears. Now topic is clear, basic concept is clear regarding that topic. So now I will solve that one important question. So look at this question now, that is check whether the function is given fx is equal to x plus 1 when x greater equal to 0 and 1 minus 2x if x less than 0 have limits at x equal to 0 comma 1. So you have to check this function have limits or gives limiting value or not, either it has a limit exist or not regarding that your function. At particular 2 point you have to check. One is your at x equal to 0, another is your x equal to 1. So you have to check the limiting value exist or not regarding this function at particular 2 points given. One is your x equal to 0 and another is your x equal to 1. So this is the meaning of this question. Now in my previous class you know that what is the basic geometrical meaning or mathematical analytical meaning be there. Okay, so we know if fx function fx function y equal to fx has limit or limit exist, function have limit or limit exist, have limit or limiting value exist if limit x tends to c minus fx is equal to limit x tends to c plus fx. This is left hand limit is equal to right hand limit, and that value L, and this value also your finite value. Okay, so this is the mathematical definition of the limit. The function, if you know the function have limit or limit value exist if left limit, this is your left hand limit, left limit is equal to right hand limit. If these two left limit equal to right hand limit and that value gives finite value, then this function gives limiting value. Okay, so and you know already that is the meaning for the, if you draw one diagram, that is your particular point. Yep, that is here is C point, particular point is C. If I write here fx have limiting value, limit at x equal to c, then that condition, okay, c minus, that is x equal to c, this is c plus, c minus means it comes from left side, that is your x negative, and it comes from right side, that means c positive. Last class we already discussed, this is your c plus, this is your c minus, and this is your particularly c x equal to c point. Okay, so this is the definition of the limiting value. Okay, so note please, and with this form or with this formula, you can say the formula definition you can use in your particular question. Okay, so note please. Now the given function is you can see here fx is equal to x plus 1, x greater equal to 0, and 1 minus 2x is x less than 0. Now we have to check for first point x equal to 0. So at x equal to 0 we have to check this function gives limiting value, yes or no. Okay, so at x equal to 0 means you can draw like that way, draw one number line, that is your minus infinity, plus infinity, and you can say this is your virus point also, but because we have to work on that particular point, if roughly you can think that this point is my virus point. Okay, so you have to attack that point from left side attack from that point, attack this to this point from left side, and attack this point from right hand side. Okay, so x equal to 0, particular point you have to check either this function is gives limiting value or not. Okay, so now it comes from left side. When you can find left hand limit, so it comes from left side, so that region it comes from left side and close to 0, that is your 0 negative, you know. Close to 0 means you can take any value, you can close to value any, you can take any value from left hand side. Take like that 0 point, sorry, that is your minus 0 point just 0 1. You can take also minus 0 point, because this is the left hand side, from left, that is this point is your negative value, so minus 0 0.01. Obviously this value is less than 0. Obviously this value is less than 0, so that means in that situation, the value of the function fx equal to 1 minus 2x. Why? Because according to your question, if x less than 0, so the value of the function is 1 minus 2x. When you comes from left side, 2x equal to 0, so whatever value you take, obviously that value is less than 0, and that time the value of the function fx equal to 1 minus 2x. So left hand limit, you can see that form, limit x tends to c negative fx is equal to, that is, here is c means actually particular point, so you can write here 0 negative fx is equal to limit x tends to 0 negative, and that time the value of the function you can substitute here, so that is value of the function is 1 minus 2x. Now you can substitute here x replaced by 0. If x tends to 0 negative, that means that time you have to check the function where goes to. Okay, so that means put x equal to 0 means 1 minus 2 into 0, that means this limiting value goes to 1. That is your left limit, that is your left hand limit. So left hand limit goes to 1, limiting value is 1. Okay, so now next we can find out the right hand limit also. Now copy please. Now you have to check for right hand limit, at x equal to 0. Okay, so right hand limit means limit x tends to, that is your 0 positive fx, because you know that if I draw the diagram minus infinity plus infinity, here is your, that is your x equal to 0 point and comes to your right hand side. You have to comes from right hand side close to 0. So that means this point is your 0 plus, and whatever value you have to take from that side, obviously this is x greater than 0. Obviously x greater than 0, because you can take, that is like point 0.0001. You can take like that point. Obviously this point is greater than 0. If greater than 0, according to your question, you can see that value goes to x plus 1. That situation, the function value gives x plus 1, because whatever value you take from right side, obviously x greater than 0. Whatever close value, 0.0001, 0.1, because all values is greater than 1. Whenever you see that all values means greater than 0, that is all values is greater than 0, that means the function gives the value x plus 1. Look at this definition. Okay, so that time you can substitute limit x tends to 0 plus, that is x plus 1. This fx gives x plus 1 because x greater than 0, that value. And now limiting value you can substitute here 0. So 0 plus 1 is your 1. So you can see now that is left hand limit is equal to right hand limit, and that value gives 1, that is your finite value. So obviously this function, this fx function gives limiting value, that means limit at x tends to 0 fx exists and value is equal to 1. Okay, so now your job is done for only x equal to 0. Now is over. For x equal to 0, you see that left limit is equal to right limit and the value is 1, so limit value is exist. Now one thing is remaining, that is again you have to check for 1 point also. Okay, so copy please. Now we have to check for the point x at x equal to 1. So at x equal to 1 we have to check. So you can draw that diagram also. That is your minus infinity, this is your plus infinity. Here is we have to check on the point x equal to 1. You can say roughly, you can think that this is your virus point, and you have to attack that point from left side and close to, okay. And similarly, whenever you, this is your left hand limit, obviously left side, and when it comes to right hand side, attack to that virus point, you can say roughly thinking that now it is your, sorry, this is your left hand limit, this is your left hand limit, and this is your right hand limit. It is comes from left hand side, that's why left hand limit, and it comes from right hand side, that is your right hand limit. Okay, so attack this. Now you have to find first left hand limit. Okay, so when you can see that from left side, whenever you attack, that is close value you have to take. So whatever value you can take, that is let us take this is point is 0.999. so obviously this point close to 1, and obviously that point also greater than 0. You can see now that value is greater than 0. So why you observe that either greater than 0 or not? Because according to your question, that function is given, function is break at the point 0. So we have to focus on your 0 point. So that's why whatever value you take here, that is x equal to 0.999, that value is close to 1 from left side, and that value also greater than 0. So whenever greater than 0, our need is we have to check the function value. That time the value of the function fx is, that is x plus 1. Okay, so from that situation, close value you have to take. Not only that, you can take so far away like minus 1, minus 2. You have to check whatever point you have to take close to 1. Okay, similarly, whenever you check for right hand limit, now close to 1 from right side, so you can take that point. You can take that point also 1.00001. Obviously this point also greater than 0, 1.001 also greater than 0. So why we have to focus 0? Because I repeat again, this function break at the point 0 according to your definition. So that's why you have to focus on 0. So whatever value you take, either less than 0, greater than 0, you have to check. So here that closed, all closed values greater than 0. So obviously in that situation, if x greater than 0 means that time also function gives fx equal to x plus 1. Okay, now comes to your solution. Left hand limit, you can write limit x tends to 1 negative fx, and that time limit x tends to 1 negative fx means that time whenever it comes to left side, that time function value is x plus 1. You can substitute here, and here put here x limiting value x equal to 1, so 1 plus 1, you got the value 2. Okay, so left limit approaches, that time the function approaches to 2 at the when the value approaches to 1. Okay, so note please. Now comes to your right hand limit, also we can solve. Now you can check for right hand limit, that is limit x tends to 1 plus fx, that is limit x tends to, when it comes from right hand side, that time also the value of the function is x plus 1. So that is also put here x plus 1. That is again got your value 1 plus 1 is 2. So you can see now left limit is equal to right limit, and that approaches to 2, and 2 is your finite number. So that's why limit exists. You can write here also, that is limit x tends to, here is 1 fx exist, and the value is equal to 2. So in that way you can solve that question. Okay, so now comes to your another question number 2, that is check limit x tends to 2 box x exist or not. So that is function is given fx is equal to box x, here fx equal to box x, and you know that in your function chapter, that is your greatest integer function less equal to x. So in that question you have to check either limiting value exist or not at that particular point x equal to 2. Okay, so now comes to your solution, that is actually look at let us take that is function fx equal to given fx is equal to box x. Okay, and we have to check at x is equal to 2 points. So here virus point is 2. You can roughly think again that virus point is 2. So you can draw the diagram also. That is, if you look at this diagram, minus infinity plus infinity, and this is your x equal to 2 is your virus point. You can check like that way. And again you have to check left limit as well as right limits. Now first comes to left hand limit, that is it comes from left hand side close to 2, that is 2 negative. So whatever value you take, close value you can take like that 1.9999, whatever close value you have to take. In that situation, so what is the value of the function? You know the fx equal to box x. That means whatever value you have to take, that value you have to substitute here. So that time what is the value of the function? That is, you have to find the value of the x replaced by 1.999. So box of 1.999 represents the value 1. You know this is a box function. Box function is greatest integer function which is less equal to 1. And if you don't understand, so look at this. So look at this box function, meaning if I take 1.999, let us take this is your 1.9 or 1.999, whatever. Okay, so we have to check all integers up to 1.999. Okay, whatever integer you have to take, less equal to 1.999. Less equal to means that side. This is your minus infinity, this is your plus infinity. So whatever integer you can take. So 1.999 less integer means you can take 1. You can, next integer is your 0, then minus 1, and so far. Okay. So in between this integer, so which integer is the greatest? So here you can see, easily say that 1 is your greatest integer. So that's why box of 1.999 represent 1 value. Okay. So whatever value you take from left hand side close to 2. So obviously that value, that box value gives your 1 value. Okay. So comes to your solution. Left limit is equal to limit x tends to 2 negative fx. That means limit x tends to 2 negative fx means box x, and whatever value you take, obviously function gives, that is your box function gives 1 value clearly. So directly you can write here 1. Whatever value, close value you can take from left side, 1.99999, 1.9, 1.98, whatever value, close value we can take and find out the solution is box that value gives 1 value. Okay, so limiting value of that position is equal to 1. Similarly you can find your right hand limit also. Limit x tends to 2 positive fx. That means limit x tends to 2 positive box x. And again you can check from right side. Right hand limit means right side. This is your left hand limit. This is your right hand side. This side, right from right side. So whatever value you take, this is your 2 plus. So whatever close value you have to take, you can take like that 2.00001, 2.100 times 01. So whatever value you would have to, you can take, with any value you can take, that time box value gives obviously 2, because this is the greatest integer. Box is your greatest integer function less equal to x. So if I take again 2.001, so whatever integer comes that are less than 2.001, and less than 2.001 means 2 comes, 1 comes, 0 comes, minus 1, minus 2, minus 3, all integer became. And in between that integers you have to search which integers is the greatest. That time obviously 2 is the greatest. That's why this is the greatest integer function. So obviously whatever value, close value you can take, that value gives, box function gives 2 value. Fx is equal to 2 value. So here also you can put here 2. Now you see that left limit not equal to right limit, because there are limit, both value, limiting value are different. So that's why limit x tends to 2 fx, that is your box x, fx means box x, does not exist because of this different limiting value. So it can, in that way you can solve this type of problem, and this type of box function is a very important function. Okay, so note please. So next class again I will solve another type of question, and next class also next topic I will discuss. Next topic means next concept regarding your limit form. Okay, thank you, have a nice day.